Hi and welcome to Tech Tip Friday. I'm Kurt Stahle, that plastics guy, and guess what? I'm bringing you another tech tip that helps you understand the plastics industry just a little bit better and that you can take to the shop floor with you today. So I wanted to talk a little bit about what specific gravity or density actually means. It's a term that we throw around quite a bit in our industry, and it's a key descriptor for plastic materials. But what does it really mean? We see values 0.89, 0.9, 0.963, 1.04, 1.2, 1.4. What does it all mean? Well, it does refer to the weight of the material. And basically everything is in reference to the baseline of water, which has a density of 1 or a specific gravity of 1. Anything less than 1, well, that would float. So an unfilled polypropylene or unfilled polyethylene, you get the idea. Anything heavier than 1, well, that would sink, and that would be talc or calcium filled polyolefins. TPU, for example, with a filler, glass filler or otherwise, a filled PVC, maybe a 1.6, or I'm sorry, maybe not that high, 1.3 to 1.45, that type of thing, filled PVC obviously would sink. So what are the implications of that? Well, in kind of an interesting way of looking at this, if you cross-contaminate materials, you can actually float them in a water bath, and the heavier pellets will obviously sink. Anything over specific gravity of 1 will sink. And if you're trying to separate out, say, an unfilled polyolefin, it's your lucky day, because that will rise to the surface and float in a water bath, and that can be scooped and collected. There are a few companies that do that. It's a rather unique service, but that's a way to sort of save your bacon if you cross-contaminated two materials with different specific gravities. Now, in terms of actual processing, specific gravity really isn't that important in terms of how you set up your machine, in terms of, injection velocity or pack and hold time. What the specific gravity will tell you is if the material is filled and to what level. For example, if you have a homopolymer polypropylene that is mineral filled with the specific gravity of 1.04, that's 20% talc filled. And you just sort of pick these things up being around in the industry and looking at different materials given enough time. So it can actually tell you some things about the material, and it can give you an indication, if you're reading a material cert, if the filler level is within tolerance. And you'd compare a lot test report to a material data sheet, or at least to the specification on that lot test report for a filler. So the more filler, the heavier, higher density the material will be. The other thing to keep in mind, and I've talked about this in TPV versus PVC, we buy in a cost per pound or cost per kilo, but we're selling parts that are volumetric. So if you want to mold a part in polypropylene and you think, well, if I add 20% talc to it, I can lower the cost. Maybe you can, but you are actually creating a heavier part. And then, of course, you have to, no pun intended, weigh into consideration what filler you're putting in that material and how the physical property characteristics will alter your end product. Like many people, I bought plastic clothes hangers for my clothes in my closet. Why not? And I like white because it's kind of uniform and nice, and I'm picky, okay? Well, I've bought things that are talc or calcium filled, and yes, it's cheaper. The extra weight in a clothes hanger application, it means nothing. But the clothes hangers are brittle, and that is no fun if you're putting a heavier pair of pants or a shirt or a jacket, for example, that will have more weight. It can compromise the design, it can compromise the part. So specific gravity will lead you to further investigate the material, and you can ask yourself, well, what's in it and how is that going to affect the application? Very important if you're running reprocessed material as well. You can tell if there's a feed stream that has had a filler in, or If you're dealing with a 0.89 or 0.90, 0.91 specific gravity, then you know it's more or less an unfilled material that you're buying in repro, and you should have a fairly decent idea of how that's going to perform. So a lot of information there. Again, density, not necessarily the most important spec unless you're doing film or some type of profile extrusion where density is very key in the performance of your finished part. But for injection molding, look at it as an indicator as to what is actually in the material you're buying. And that's your tech tip for today. Take it to the shop floor, educate your colleagues, and just build awareness of one of the basic principles in material characterization. Have a great Friday, great weekend, and we will be back next week with another tech tip. Bye for now.